So quite often with wave function, we get a part B after it. And it can be one of two things. It can be something involving to do with the maximum minimum, like we were talking about earlier, or it can be something to do with solving trig equations. This one here, as you can see in part B, says hence solve. Now part A is a bog standard wave function that we've been working our way through, and then we'll talk about part B. So let's turn it out. So 2 cot cos expansion right, start equating things. I'm gonna make that be purple. Right, so cos x is there this time. So k cos alpha is 2. K sin x, positive k that, and again there's nothing there, so let's put a wee 1 in. Okay, this one's calculator one. So I don't like the way they're written. Now, it just takes 2 seconds, but I always think it keeps me right. Obviously I'd sort out negative as if I had to. I like to put a sign on top. Right, okay. So we have 1 squared plus 2 squared, square rooted, is the square root of 5. Okay, alpha SATC at this point. Actually everything's positive, so it's the first quadrant. It is in degrees this time. So tan to minus 1/2 is 26.6. So that means our alpha is 26.6 degrees. So what we got, again, rewrite it, equals root 5, go up to your question, cos x minus 22.6 degrees. Okay, that's part A. Right, part B says hence solve. Keyword is hence. So what have we just done in part A? We've just rewritten that as literally what's right above it. So root 5, now you get a mark for this, how beautiful is that? Okay, so now where your brain is going is you're saying you have a single trig function. Okay, single trig, we should really be thinking about, we're going to solve it, we're going to change our boundary, because we need to check, do we have more numbers? And we're going to work our way through it. So the first thing really is to get cos by itself. Okay, then what I'm going to do is I'm going to change my boundary because we've actually got x minus 22.6. So negative 22.6 and, don't rely on my mask, is going to say 337.4. Okay, so this is what we're going to be looking at. Right, turn out your steps. So we have negative cos, so where's that? There and there. Let's get our theta. We are working in degrees. Don't know why I wrote tan, so used to writing tan. So cos to the minus 1 over root 5, which is 63.4. Okay, so what are our values? We have x minus 22.6 is, what are we going to get? We're going to get 180 minus. Now we can just kind of turn them at the side if you want. 180 minus 63.4. 116.6 and then 180 plus is obviously going to be 243.4. So let's put them in there. Okay, we need to check if we've got any more values and looking at your boundary there. So we're going between negative 222.6 and 337.4. Now if we add on 360, it's clearly going to be too big. Also check minus 360. But if you take away 360 from 243, you're obviously not going to get, it's going to be within that negative 22.6. So we don't need to do anything with it. So then we're just going to add on the 22.6, which is going to give us 143.2 and 270 degrees. So you always need to check your boundary in these types of questions. In this one, we don't have to add anything on. That's really a common solving part after tricky